Hi everyone, welcome to my Capstone project presentation. Today I'm showcasing Flora, a premium concierge AI plant advisor. Balcony gardening is a beloved hobby, but plants often die because general advice like water twice a week fail in the real-time world. Balconies are exposed to highly dynamic temperatures, fluctuating humidity, and solar radiation. Some balconies are covered, blocking all rainfall, while others are open. Some corners get 8 hours of sun, others are in complete shade. And the most important thing, most gardeners have plants from various different species with unique water needs. The result? Some plants either drown or dry out. Let's see how Flora solves this issue. Flora is a personal concierge dashboard designed to take the guesswork out of plant care. Instead of relying on static guidelines, I built a hybrid simulation system. Why did I use AI agents? Because calculating plant health requires reasoning over multiple real-time streams of data, like geolocation, days since last watering, and microclimates, and translating raw numbers into personalized friendly care instructions. A simple calculator can give you a percentage, but an agent explains why a plant needs water and gives you species-specific tips. Here's the architecture under the hood. The front end is built with Vite and uses local storage for plant configurations, ensuring 100% user privacy and zero database hosting costs. Fast API backend communicates with a custom model context protocol MCP server to geocode the user's location and fetch live weather history from the keyless OpenMeteo API. The weather history is fed into a deterministic Python-based evapotranspiration calculator to simulate exact soil moisture depletion. Finally, the simulation data and balcony settings are sent to the Vertex AI agent runtime, where the Gemini 2.5 Flash model writes tailored explanations and care tips. I created this entire project in the anti-gravity IDE, pair programming with the agent. For instance, when designing the local image upload feature, we needed to store pictures inside local storage. Anti-gravity helped me write a canvas-based compression pipeline in main.js that resizes user-uploaded images to 800 pixels max and compresses them to 80% JPEG quality, saving precious local storage space. We also used custom agent skills to guide LLM behavior. In the botanical watering skill directory, I wrote custom system instructions that guide Gemini on how to reason about sun exposure deviations and write responses strictly in English, ensuring high linguistic quality. For deployability, the entire front-end and back-end are package wrapped into a single Docker file in the submission front-end folder, which I successfully deployed to Google Cloud Run. I set up IAM project level bindings, granting the dashboard service account the Vertex AI user role so it can query my reasoning engine securely without needing hard-coded keys in production. In addition to the production environment on Google Cloud Run, the entire application can be deployed locally using the Docker Compose setup. This local deployment option makes manual testing and iterating on features significantly faster by eliminating cloud deployment latency. Let's see it in action. When I configure the balcony settings, it runs geocoding and retrieves live weather history. I enter the AI feature password once, which grants access to the AI services on my webpage, including current weather data. If we change the location to Sydney, Australia, where it is currently winter, and run the analysis again, you will see that the last water timeline for my plants updates to reflect recent local rainfall. If we look at the basil card, Gemini generates a precise explanation pointing out that it dried faster due to its high level of sunlight exposure. Next, to show how different species behave, I create 3 plant cards from different categories. When we run the analysis, you can see they all have different moisture levels. If I change their settings to covered, so they are sheltered from rain, you can see exactly how the simulation dynamically updates the analysis results. And since privacy comes first, you can download a full JSON backup of your plants and restore it on any device without needing to sign up for an account. So, Flora demonstrates how physical calculations and generative AI can collaborate to build practical concierge tools. All source code and setup instructions are linked below on GitHub. Thank you for watching and happy gardening!